This question is a simultaneous equations question involving quadratics, involving squared terms. I actually prefer these to the more traditional linear ones because you're not changing the formulas. You're just substituting one into the other, and I think that's just so much easier. There's less, I think, less brain work involved in that side of it. So basically what we have here, we have two equations. We have 2x squared plus 3y squared equals 5. So there's an equation with two unknowns. And here we have another equation, y equals 2x squared plus 1, again with two unknowns. The y and the x are the same in both, so that's why they're called simultaneous equations. But what we can do here is, if we know that y is equal to this, then we can just substitute, we can replace y with 2x plus 1 in the first equation. We can literally just put this in here, and then we can just work with a quadratic. So let's try that. So if I substitute this and put it into here, what do I get? Well, my 2x squared stays the same. So it's 2x squared plus 3, replacing y with 2x plus 1 squared equals 5. Make sure you've got the brackets around it, because this thing here is my y. Now I need to expand this out and simplify. So let's have a look. So I've got 2x squared plus 3. I'm going to use a square bracket just to show it's a little bit different. 2x plus 1 multiplied by 2x plus 1. You may be able to actually expand the square bracket straight away. I'm going to show every single step. Let's work this through. So I've got 2x squared plus 3 multiplied by 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is 1 equals 5. Again, you can shorten some of these steps if you're confident enough to do so. So we've got 2x squared, still left that alone. The 3 I'm leaving alone because I want to tidy up my bracket first. So 4x squared plus 4x plus 1 equals 5. So 2x squared plus 3 times 4x is 12x squared. 3 times 4x is 12x. And 3 times 1 is 3. And that equals 5. Let's tidy all this up and make this equal to 0. So 2x squared plus 12x is 14x squared plus 12x. Take away 5 from both sides gives me minus 2 equals 0. That looks nasty, but I'm looking at it. All these numbers are even, so let's just divide by 2. 7x squared plus 6x minus 1 equals 0. Looks nasty. Let's just see whether we can factorize it without using the quadratic formula. First terms will have to be 7x and x. The last terms will have to be 1 and 1. Those signs will be different because we have a negative 1 at the end there. So if I put plus 1 here and minus 1 there, let's just quickly expand that out and see what we get. We get 7x squared, we get minus 1. We get plus 7x minus x, which gives us our 6x. So this is correct. Now, let's solve this. So what do we get? Well, we know then that either 7x minus 1 equals 0 or x plus 1 equals 0. The first one then, we get 7x equals 1, x equals 1 over 7, or x equals minus 1. That's not the end of the question, because we have to work out the corresponding values for y. So I'm going to put those into my linear equation here. My y equals 2x plus 1. So when x equals 1 over 7, y equals 2, multiplied by 1 over 7 plus 1. So that's going to be 2/7 plus 1. Well, 1 whole 1 is 7/7, so that's going to be 9/7. So that's one pair of solutions. 1/7 goes with 9/7. I'm going to put them in brackets, but you don't need to. We've got our mark here by showing the two values and they correspond. And let's look at x equals minus 1. X equals minus 1. Put it into my linear equation again. So y equals 2 multiplied by minus 1 plus 1. 2 times minus 1 is minus 2. Minus 2 plus 1 is going to give me minus 1. So my corresponding here is x is minus 1 and y is minus 1. Again, I'm going to put it in brackets, but would most likely not be necessary within the question. Just checking through. did we actually do what the question said? Did we show clear algebraic working? There's all my clear algebraic working. If I've done more steps probably than you would do, every step is down there. I can clearly see which are my corresponding values, and that gives me full marks in the test.